The National Electrical Code does not directly use the term non-SDS. SDS stands for Service Disconnecting Switch. It is a critical component in electrical systems. It relates to the means of disconnecting the power supply to a building or structure. The NEC, specifically Article 225.30, mandates that every building or structure must have a readily accessible way to disconnect all ungrounded conductors from the incoming power source. This disconnecting means ensures that the electrical supply can be shut off quickly and safely, especially during emergencies or maintenance. An SDS can take several forms. It might be a circuit breaker, or it could be a fuse switch. A disconnecting switch can also serve as the SDS. The key characteristic is its ability to interrupt the flow of electricity from the source to the building. Considering this definition, APS, or uninterruptible power supply, can function as an SDS under specific circumstances. A UPS is designed to provide backup power to critical loads during a power outage. When the main power source fails, the UPS seamlessly switches to battery power, ensuring that the connected equipment continues to operate without interruption. In the context of an SDS, a UPS acts as the disconnecting means for the critical loads it supports. If the UPS is capable of completely isolating these loads from the main power supply, effectively acting as a switch to the incoming power, then it can be considered an SDS. This is because it performs the essential function of disconnecting the power supply. To determine if a specific UPS qualifies as an SDS, several factors must be considered. Firstly, the UPS must be capable of disconnecting all ungrounded conductors from the source of supply. This means that when the UPS switches to battery power or is manually shut down, it completely isolates the connected loads from the utility power. Secondly, the disconnecting means must be readily accessible. This means that the switch or breaker that disconnects the UPS from the main power supply must be easily reachable by authorized personnel. Thirdly, the UPS installation must comply with all applicable requirements of the NEC, including proper wiring methods, overcurrent protection, and grounding. Now, to delve deeper into the requirements outlined in NEC Article 225.30, it states that each building or structure shall be supplied by one feeder or a branch circuit unless specifically permitted otherwise. Where a building or structure is supplied by more than one feeder or branch circuit, a means shall be provided to disconnect all ungrounded conductors from all sources of supply. This disconnecting means shall be grouped and identified. The location of the disconnecting means is crucial. It must be installed at a readily accessible location either inside or outside the building or structure, nearest the point of entrance of the conductors. The disconnecting means must also be marked to indicate the source of supply. These markings should be durable and clearly visible. The purpose of these requirements is to ensure that emergency responders and maintenance personnel can quickly and easily disconnect all power to the building or structure in case of an emergency or when performing maintenance. Now, in the case of a UPS system, it is essential to ensure that the UPS is installed in accordance with these requirements. If the UPS is serving as the SDS for the critical loads it supports, it must be located at a readily accessible location, and it must be properly marked to indicate that it is the disconnecting means for those loads. Furthermore, the UPS must be capable of disconnecting all ungrounded conductors from the source of supply. This typically involves a combination of internal switching mechanisms and external disconnect switches. The internal switching mechanisms within the UPS automatically switch to battery power when the main power supply fails. However, an external disconnect switch is often required to completely isolate the UPS from the utility power for maintenance or other purposes. This disconnect switch must be readily accessible and clearly marked. It is also important to consider the overcurrent protection requirements for the UPS system. The NEC requires that all conductors be protected against overcurrent, such as short circuits and overloads. This protection is typically provided by circuit breakers or fuses. The overcurrent protection devices must be sized appropriately for the conductors they are protecting, and they must be readily accessible for inspection and maintenance. In the case of a UPS system, The overcurrent protection devices must be installed both on the input side of the UPS and on the output side of the UPS. The input side overcurrent protection protects the UPS from faults in the utility power supply, while the output side overcurrent protection protects the connected loads from faults within the UPS or in the load circuits. Another important consideration is grounding. The NEC requires that all electrical systems be properly grounded to provide a low impedance path for fault currents. This grounding helps to protect people and equipment from electrical shock and damage. The grounding system must be installed in accordance with the requirements of NEC Article 250. In the case of a UPS system, the grounding system must be carefully designed to ensure that the UPS and the connected loads are properly grounded. This typically involves connecting the UPS chassis to the building grounding electrode system and providing a separate grounding conductor for the connected loads. Understanding these requirements is crucial for ensuring the safe and reliable operation of UPS systems. Now let's consider some practical examples to illustrate how these principles apply in real-world scenarios. Imagine a small office building that relies on a UPS system to provide backup power to its computer servers and network equipment. The UPS is installed in a dedicated equipment room, and it is connected to the main power supply through a dedicated circuit breaker. The circuit breaker serves as the SDS for the UPS and the connected loads. It is located in the main electrical panel, which is readily accessible to authorized personnel. The circuit breaker is clearly marked as the disconnecting means for the UPS system. In the event of a power outage, the UPS automatically switches to battery power, ensuring that the computer servers and network equipment continue to operate without interruption. If maintenance is required in the UPS, the circuit breaker can be turned off to completely isolate the UPS from the utility power. This allows maintenance personnel to safely work on the UPS without the risk of electrical shock. Now, consider a larger data center that relies on multiple UPS systems to provide backup power to its critical IT infrastructure. In this case, each UPS system may have its own dedicated SDS, or a single SDS may serve multiple UPS systems. The location and accessibility of the SDS are critical to ensure that emergency responders and maintenance personnel can quickly and easily disconnect power to the UPS systems in case of an emergency or when performing maintenance. The SDS must be clearly marked to indicate which UPS systems they control. Furthermore, the data center's electrical system must be designed to ensure that the UPS systems can be safely and reliably disconnected from the utility power without disrupting the operation of other critical equipment. This may involve the use of redundant power supplies and automatic transfer switches. It is also important to consider the impact of the UPS system on the overall power quality of the electrical system. UPS systems can generate harmonic currents, which can distort the voltage waveform and cause problems with other electrical equipment. To mitigate these problems, it may be necessary to install harmonic filters or use UPS systems with advanced harmonic mitigation capabilities. In summary, while the NEC doesn't explicitly use the term non-SDS, the concept is implicitly addressed through the requirements for service disconnecting means. A UPS can be considered an SDS if it meets the requirements outlined in NEC Article 225.30, including the ability to disconnect all ungrounded conductors from the source of supply, readily accessible location, and proper marking. When determining whether a UPS qualifies as an SDS, it is essential to consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable requirements of the NEC and other relevant standards. It is also important to note that the specific requirements for UPS systems may vary depending on the application and the local electrical codes. Therefore, it is always best to consult with local authorities to ensure that the installation meets all applicable requirements. Furthermore, the NEC is updated every 3 years, so it is essential to stay up to date on the latest requirements to ensure that electrical systems are installed and maintained in accordance with the most current standards. The NEC is a comprehensive document that covers a wide range of electrical topics, so it is essential to have a thorough understanding of the code to ensure that electrical systems are installed and maintained safely and reliably. In addition to the NEC, there are other relevant standards that may apply to UPS systems, such as the UL standards for safety and performance. These standards provide additional guidance on the design, testing, and certification of UPS systems. By following these standards, manufacturers and installers can ensure that UPS systems meet the highest levels of safety and performance. Finally, it is important to emphasize the importance of proper training and education for electrical workers. Electrical work can be dangerous, and it is essential that electrical workers have the knowledge and skills necessary to perform their jobs safely and effectively. This includes understanding the requirements of the NEC, as well as other relevant standards and best practices. There are many resources available for electrical training, including apprenticeship programs, vocational schools, and online courses. By investing in training and education, electrical workers can improve their skills, enhance their safety, and advance their careers. Moreover, continuous professional development is essential for staying up to date with the latest technologies and best practices in the electrical industry. As technology evolves, new challenges and opportunities arise, and it is important for electrical workers to adapt and learn new skills to remain competitive in the workforce. This can be achieved through attending industry conferences, participating in online forums, and reading trade publications. In conclusion, understanding the role of UPS systems in relation to service disconnecting switches requires a careful consideration of the NEC requirements, particularly Article 225.30. While the code does not explicitly mention non-SDS, the principles of disconnecting means and readily accessible power shutoff are paramount. By ensuring that UPS systems meet these requirements, we can enhance the safety and reliability of electrical systems in buildings and structures. It is always advisable to consult with qualified professionals and stay informed about the latest updates to the NEC and other relevant standards to ensure compliance and best practices. Furthermore, regular inspections and maintenance of UPS systems are crucial for ensuring their continued proper functioning and safety. This includes checking the battery condition, verifying the operation of the switching mechanisms, and inspecting the wiring and connections. By implementing a comprehensive maintenance program, building owners and operators can minimize the risk of UPS failures and ensure that their critical loads remain protected during power outages. In addition to the technical aspects of UPS systems, it is also important to consider the environmental impact of these systems. UPS systems typically use batteries, which can contain hazardous materials. Therefore, it is important to properly dispose of used batteries in accordance with local regulations. Some UPS manufacturers offer battery recycling programs to help ensure that batteries are disposed of safely and responsibly. Furthermore, there are ongoing efforts to develop more sustainable UPS technologies, such as those that use renewable energy sources or have improved energy efficiency. By adopting these technologies, we can reduce the environmental footprint of UPS systems and contribute to a more sustainable future. In addition to the technical and environmental considerations, it is also important to consider the economic aspects of UPS systems. UPS systems can be a significant investment, so it is important to carefully evaluate the costs and benefits before making a purchase. The costs of a UPS system include the initial purchase price, installation costs, maintenance costs, and battery replacement costs. The benefits of a UPS system include improved power reliability, reduced downtime, and protection of critical equipment. By conducting a thorough cost-benefit analysis, building owners and operators can make informed decisions about whether to invest in a UPS system and which type of system is most appropriate for their needs. Moreover, government incentives and tax credits may be available to help offset the costs of purchasing and installing UPS systems. These incentives can make UPS systems more affordable and encourage their adoption in a wider range of applications. Finally, it is important to remember that UPS systems are just one component of a comprehensive power protection strategy. Other components may include surge suppressors, voltage regulators, and backup generators. By implementing a multi-layered approach to power protection, building owners and operators can minimize the risk of power-related problems and ensure the continued operation of their critical equipment. This approach should be tailored to the specific needs of the facility and should be regularly reviewed and updated to reflect changes in technology and operating conditions. Therefore, a holistic perspective is vital, integrating technical expertise, environmental responsibility, economic considerations, and a multi-layered power protection strategy. This comprehensive approach ensures the safe, reliable, and sustainable operation of UPS systems, contributing to the resilience of critical infrastructure and the protection of valuable assets.